Okay, so today we're going to finish up section 5. We're going to finish up the rational expressions. Today what we're going to cover are complex fractions. So when we have a complex fraction, we call it the quotient of two rational expressions, and that's what a complex fraction is. Technically, all it is a fraction in a fraction. So what we're going to do, and there's different techniques out there that'll teach you how to simplify or solve these complex fractions. However, what I'm going to do is, the technique I'm going to show you is just, we're going to simplify or simplify the numerator, simplify the denominator, and then we're going to just divide. So again, the book has different methods that you can do, but all I'm going to do is simplify each part. So again, remember, if I gave you a problem like, say, 3/4 over 5/6, this is probably something you saw in middle school. This is a complex fraction. It's a fraction in a fraction because we have this fraction bar here. So what we're going to do here, remember the fraction bar means division, so we would really be doing 3/4 divided by 5/6, and then remember when we multiply fractions, we do a keep, flip, change or a stay, change. We're multiplying by the reciprocal. So we keep the first or the top fraction the same, we change it to multiplication, and then we flip it upside down. And now we multiply straight across. So I could do 3 times 6 and get 18, and 4 times 5 and get 18 over 20, or I can simplify before I multiply. And I could change this to a 2, this to a 3, and then get 9 over 10. So this is basically a simplified process of what we're going to be doing here. So let's go ahead and take a look at our more complex fraction here. So again, I'm going to treat my problem as 3 different things. I'm going to first subtract the numerator, find a common denominator. I'm going to subtract the denominator, or add the denominator, find a common denominator, and then once I get those two simplified things with a common denominator, I'm going to divide them. So let's do the top first, the red. So I have 6 minus 5 over x. I need to find a common denominator here. So technically I could do this. And you can see that the common denominator is going to be x. So this one already has the x. All I need to do is multiply the numerator and the denominator of my first fraction by x. So this will become 6x minus 5 over x. Now I'm going to simplify the denominator. And the denominator here is in blue. So again, I could put 1 over 1, 5 over x. Again, you can see your common denominator here is going to be x. So this fraction is missing the x. So now this one would simplify to x plus 5 over x. Let me switch my highlight colors here so it matches the final answer. So I'll do this one in red and this one in blue. Okay, so now here is my complex fraction now. I now have 6x minus 5 over x over x plus 5 over x. So again, this fraction bar right here means division. So what I should be doing here is 6x minus 5 over x divided by x plus 5 over x. So again, remember, you're going to do your keep, flip, change or your stay, change. So I'm going to keep the blue fraction the same. I'm going to change the problem to multiplication and flip the red fraction upside down. And now I'm going to look for things to simplify. So I can only simplify the x's. I cannot simplify anything else. So now I'll multiply. And my final answer is 6x minus 5 over x plus 5. So again, we're combining adding and subtracting and multiplying and dividing all into one lesson here. Let's try another one. So here is my fraction bar. So again, I'm going to simplify and add the numerator. I'm going to add the denominator. Once I get my two answers, then I'm going to divide them, which is really turn it into the reciprocal and multiply. So for my first fraction, you can see that the common denominator has to be both. So the common denominator here is going to be a and a plus 1. So the first fraction, you can see it's missing the letter a. So I'm going to multiply the numerator and the denominator by a, and I'm left with a squared. The second fraction is missing the a plus 1. I'm now going to add the numerator, and I end up with a squared plus a plus 1 all over a times a plus 1. I'm now going to do the same thing to the denominator that I've boxed in blue here. Okay, so again, same thing. It's the same denominator, coincidentally enough. It always won't be like this. It just happens to be a coincidence. So again, my common denominator here for both of them is the a and the a times the a plus 1. The first fraction's missing the a plus 1. So let me write that, because 1 times anything is itself. So 1 times a plus 1 is just a plus 1. And over here, this one's just missing the letter a. I now can add my numerator, and I get 1a plus 1a is going to be 2a plus 1 over the a times the a plus 1. So here is my simplified denominator, and here is my simplified numerator. I now have to divide them, because again, here's my complex fraction. So again, I'm going to write the numerator. I keep it the same. So a squared plus a plus 1 over a times a plus 1. Because I'm dividing, I'm going to flip this fraction upside down. So the a times the a plus 1 becomes the numerator, and the 2a plus 1 is the denominator. I now again look for things to simplify. The only thing that I can simplify are the a times the a plus 1. I can't factor that trinomial, so I'm going to just go ahead and now multiply. So my final answer here is going to be a squared plus a plus 1 over 2a plus 1. Final answer. And again, there are other techniques out there, but I think this is the easiest way if you just simplify each piece and then divide, which is really multiply by the reciprocal. Let's try another example. Try number 3. So again, let's look at each piece. So again, take care of your numerator and then take care of your denominator. So for the numerator, I need to find a common denominator. And let's do it in red. So right now I have 2 over 1 minus 2 over y. You can see that the common denominator is going to be y. So this one needs a y. Whatever you do the bottom, you do the top. So now it becomes 2y minus 2 over y. For the denominator, same thing. The denominator is going to be y. So if I put 2 over 1 again, but this time it's a plus sign. This one's missing a y. So now it becomes 2y plus 2 over y. Here's your complex fraction now. Again, fraction and a fraction means division, so we are going to divide, which really is multiplied by the reciprocal. So, and I should have done this in blue, so this one's blue. So the red one is 2y minus 2 over 2. Flip the one I just boxed in blue. Put the y, and this is a y, sorry. That's a y, and that should be red. And now here, flip the denominator fraction upside down. And now we'll look for things to simplify. So I can simplify the y's. And now I'm left with 2y minus 2 over 2y plus 2. Now, notice they both have a GCF that I can factor out. So I need to simplify that answer. So I'm going to factor out a GCF of 2 out of both. So if I factor the top, it becomes 2 times y minus 1. And the denominator becomes 2 times y plus 1. Yes, they do. So then final answer, y minus 1 over y plus 1. So technically on your test tomorrow, you could get a question that looks like this green here that I just boxed in yellow, and it may say simplify that fraction. And then you're going to need to know that you're going to factor out the GCF and cancel the 2's. Okay, so again, I am going to simplify my numerator. Find a common denominator, subtract them. The denominator here is, I can't simplify it. So the only thing I have to work on right now is the numerator, and then I'm going to divide. So my common denominator, again, needs to represent both pieces here. So my common denominator is going to be x times x plus 3. Let me write it underneath both. It's a subtraction sign. So you can see the first fraction, it's missing an x. So whatever you're going to multiply to the bottom, you do to the top. And then the second fraction is missing the x plus 3. Now, remember back when I taught the adding and subtracting, I had that caution with the pink stars or whatever it was. Remember, I need to distribute this subtraction sign to both of the terms in here. So this is going to become x minus 3 over the x times the x plus 3. I'll now simplify and combine my like terms in the numerator. And this now becomes negative 3 over x times x plus 3. And so this is really the blue, and this will be the red when I write it. So now that's your simplified numerator. The denominator, I can't do anything, so I'm just going to write it as 1 over x. So now, again, division. We're going to flip that red denominator. So the blue one, let me rewrite. And then I'm going to flip the denominator to the reciprocal. The x's will cancel. And I'm left with negative 3 over x plus 3. We're trying to stay nice and organized, write nice and neatly, so you don't get lost. You could also pull the negative sign out front of the fraction. Again, it still would mean the same thing. All right, so again, I am going to simplify my numerator by finding a common denominator. The denominator here of the complex fraction doesn't need to be simplified. I'm just going to flip it to the reciprocal. So the only thing I need to work on right now is the numerator. So here, my common denominator, if I put a 1 here, is going to be x squared minus 16. Now, I will factor this, but for right now, I'm just going to leave it as the x squared minus 16. So the first fraction is good. It has everything it needs. This one just needs x squared minus 16 multiplied to the numerator and the denominator. And actually, let me distribute it. I'll do it right here. So I'm going to distribute x to the x squared minus 16. And I'm going to make it x cubed minus 16x. All right, now I'm going to add my numerator. So I get 3 plus x cubed minus 16x over x squared minus 16. Now I still have my denominator here. So now I need to divide. So now my problem becomes, here's the red. I'm dividing it by the blue, so I'm going to flip it to the reciprocal. Now, notice if you look at it right now, nothing cancels. Remember, when we have a multiplication problem or a division, we need to factor. So I'm actually going to factor this x squared minus 16. It's the difference of two squares. And I'm going to change this to x plus 4, x minus 4. Now I have something that will simplify, the x minus 4. And now I'm going to multiply what remains. And I end up with 3 plus x cubed minus 16x over x plus 4. Now, if you'd rather rewrite your numerator in standard form, you could put x cubed minus 16x plus 3 over x plus 4. Either one would be fine. Yes?
But because the numerator is 3 over x squared minus 16 plus x, don't you have to do the x to the 3?
X to the 3.
Sorry, like x.
Oh, okay.
X to the 3. So like in the end, it'd be like 3x.
Okay. So right here, see this x? Let's see, this x you're talking about?
Yes.
Okay. So think of this as like a whole number. And to make a whole number into a fraction, we're going to change this x to an x over 1. So it's really not in the denominator. That's why I don't multiply it to the 3. Does that make sense?
Yeah.
Okay. Okay. And that's it. You can't simplify anything else there. X cubed minus 16x plus 3 can't be factored, so we can't get anything to cancel with the x plus 4. Okay, so your homework, and this same problem. Okay. I was going to show you a different technique, but I think that way is the easiest. All right, so this homework, that is 59 through 65, all, and again, it's not that many problems. What is it? 6 problems. It's not due until Wednesday. All right, so what I want you to focus on tonight is studying for your test. Okay, and then tomorrow night, because you're taking the test in class, you're going to do this for homework.